friends, how are you? I hope you are well. Today in this video, I am going to explain periodic classification of elements. In fact, this is the introduction class. So definitely we will discuss some of the concepts, the necessity of classification of elements, different attempts made by different scientists from time to time to classify the elements. We will discuss about the Mendeleev's periodic table, its drawbacks, modern periodic table, its drawbacks, how the different properties varies in a period and also in a group. So, since it is the introduction class, I shall prefer to go through the concept. So, today's topic is periodic classification of elements. The elements, every substance will find elements. No doubt at all. But question comes, what is that element? In the lower classes you might have been studying what are the different elements, what is element. So from the beginning, before explaining about the classification of elements, we will discuss what is that element. So, lower classes you might have studied the simplest form of matter which can be decomposed into more simpler, or you can say the substance made up of similar atoms. We say element. But since it is the 10th class, I would like to give a different definition which will be more appropriate for you. What is that? The substance made up of atoms of the same atomic number. I have not written same kind of atoms. If I say substance made up of same kinds of atom, it will be correct, no doubt, but not exactly correct. If I say substance made up of similar kind of atoms, it is correct, but not exactly correct so far as 10th class is concerned. Then what is correct and what is exactly correct? Exactly correct is the substance made up of atoms of the same atomic number. I shall give one example. Let us see. For example, hydrogen. The name of an element is hydrogen. Whenever I say hydrogen, it is a diatomic molecule. In the diatomic molecule, in the sense, we used to write H2. But in this hydrogen, two hydrogen, suppose one hydrogen mass is 1, another hydrogen mass is 2. You have studied about the isotopes. So hydrogen having 3 isotopes: protium, deuterium and tritium. Here mass is 1. because proton 1, neutron is 0. In normal hydrogen, we find 1 proton, no neutron. That's why its mass is 1. But out of 20,000 average, 1 hydrogen is there, where you can find it contains 1 neutron. That means if proton is 1, neutron is 1, its mass is 2. This is called a deuterium. Similarly, very few hydrogens are there which contains 2 neutrons. That means 1 proton plus 2 neutron. That means its atomic mass number is 3. All are hydrogen. If I say that this hydrogen molecule is made out of these 2 types of hydrogen, then both are not the same kinds because its atomic number is 1, no doubt. Hydrogen atomic number, all hydrogen atoms atomic number is 1. Atomic number just like our fingerprint. How the fingerprint of one person does not match, it will not match with others. Similarly, atomic number of every element is distinct from other elements, different from other elements. So, both hydrogen atomic number is 1 because both are hydrogen, but their masses are different. Here mass is 1, here atomic mass is 2. Mass number is 1, atomic mass number is 2. So I can't say same kind of atoms. In lower classes, children, they can't understand. We used to say that same kind of atoms. But if I say kind of atoms, it is correct, but not exactly correct. Because both hydrogen atoms masses are different. So I can't say they are the same kind of atoms. Instead of that, I can say that both having the same atomic number. That's why the definition I have written, the substance made up of atoms of the same atomic number. It is exactly correct. So this is the definition of an element. The topic is periodic classification of elements. So far, 118 elements have been discovered. So far, about 118 elements have been discovered. 118 elements, they have millions of compounds are there. It is difficult to study the properties of all these elements separately and also the properties of the compounds made by these elements. So scientists thought that if we can classify the elements, classify in the sense, make some groups, in which group those having the similar properties they will be. So scientists thought those elements having similar properties, if we can make them in a groups, then it will be easy to study, it will be easy to remember. For that purposes, different scientists tried in different manner to classify the elements. So, in this connection, here I am going to discuss some of the attempts, or you can say some extent successful attempts made by different scientists from time to time to classify the elements. I said that the reason behind the idea of classification of elements to study the properties systematically in an easy manner. For that purposes, scientists decided to classify the elements patents made by different scientists. We are going to discuss it. So, in this connection, the first remarkable attempt was made by one German scientist, John Dobereiner. So, first I am going to explain what is Dobereiner's triad. See here, it is the matter of 1870. The matter of 1870, almost 30 elements were discovered. When Dobereiner tried to classify the elements, about 30 elements were discovered. He observed that some elements having similar properties, and it is possible to keep all those elements having similar properties in a group. During that time, they used to say that group is the family. So, the first attempt, or you can say first remarkable attempt, made by German scientist Dobereiner. He proposed a law. What is that law? I am writing, thereafter I shall explain it. When the elements are arranged according to the increasing order of their atomic masses. When the elements are arranged according to the increasing order of their atomic masses, a group of 3 elements called triad are obtained. Three elements called triad of similar properties are obtained, and the atomic mass of the middle element of the triad being triad, or you can write, is roughly equal to the arithmetic mean of remaining 2 elements of the triad. When the elements are arranged according to the increasing order of their atomic masses, a group of 3 elements what we say triad of similar properties are obtained. At the same time, the atomic mass of the middle element of the triad is roughly equal to the arithmetic mean of remaining two elements of the triad. During that time, I said about 30 elements were discovered. At present, we have so far been discovered 118 elements. Okay? But out of that 118 elements, few elements like gold, copper, silver, tin, lead, mercury, it helped a lot for the development of a different civilization. That means ancient time we knew only few elements. Okay? But during the Dobereiner triad, 30 elements were so far discovered. Okay? So, according to the Dobereiner, if the elements are arranged according to the increasing order of their atomic masses, a group of 3 elements are obtained, and in that group all elements having similar properties. At the same time, the atomic mass of the middle element is roughly equal to arithmetic mean of remaining 2 elements of the triad. Let us see the group prepared by Dobereiner. First one is the alkali group. The alkali group. What are the alkali group? He proposed 3 elements: lithium, sodium, potassium. So the mass of lithium is 7, sodium is 23, potassium is 39. These 3 elements all are metals. All are metals. All having the valency 1. All react with water. They form alkalis and hydrogen gas. That's why they are said to be alkali metals. They are basic in nature. You see that middle element sodium, its atomic mass is the average of lithium and potassium. Lithium is 7, potassium is 39, divided by 2, 46 upon 2, that is equal to 23. That means the mass of sodium is the average of lithium and potassium. What I said, arithmetic mean of lithium and potassium. So in this case it is exactly 23. Some cases may not be 23, but it will be roughly equal. There is no doubt at all. So this is one of the group proposed by Dobereiner. Second one, alkaline earth metals. The alkaline earth metals. The alkaline earth metals. So this is one more group. This is calcium, strontium, barium. If I say the atomic mass of calcium, this is 40, this is 88, this is 137. Calcium, strontium and barium, they are called alkaline earth metals because, and all these 3 elements have similar properties. All are metals. All are hydrogen they make the oxide like strontium oxide, calcium oxide. The oxides are basic in nature. Oxides are basic in nature. That means all three are having the similar properties. And so far as the atomic mass is concerned, for example, this is 137 plus 40 divided by 2. This is equal to 177 divided by 2 is equal to 86.5. This is the 86.5. This is nearly equal. So this also satisfied the condition. One more group was also suggested by Dobereiner, that is halogen group. So children, you know chlorine, fluorine, bromine, iodine, these are the halogens. Here he proposed chlorine, bromine, iodine in one group. You know chlorine atomic mass is 35.5, whereas the bromine is 80, whereas the iodine is 127. These three are the elements belongs to halogen, because when they react with a metal they produce salt. That's why they are said to be halogens, means salt producer. And all are the non-metals. Here all are the non-metals. What about the valency? Their valency is 1. Okay, and when they react with water, they make acids. With water, they make acids. That means I want to say that all are having the similar properties, and the atomic mass of the middle element is roughly equal to arithmetic mean of remaining two elements. These three groups were proposed by Dobereiner, but his idea failed. What are the reason why did his idea fail? That means I am going to say about the drawbacks of Dobereiner triad. Drawbacks of Dobereiner triad. What are the drawbacks? The thing is that he could not erase all those elements were available in that time in a group. All elements were not arranged in a group. Second thing is that elements like nitrogen, like phosphorus, like arsenic, these three elements were available during that time, and their properties also similar, but it was not possible to arrange in a group according to his law. The reason is that nitrogen atomic mass is 40, phosphorus atomic mass is 31, arsenic atomic mass is 75. If I add this 75 plus 40 divided by 2, that means 89 by 2 is equal to 44.5, which is not equal to 31. It is also not near to 31. So, first reason I said, those elements were discovered. He could not arrange all these elements in triads. And second thing I said that the elements nitrogen, phosphorus and arsenic having similar properties. Instead of similar properties, it is not possible to arranged in a triad because it did not satisfy the condition that the atomic mass of the middle element is roughly equal to arithmetic mean of first and third element of the triad. So students, I hope that you understood this one. So in my next video, we will discuss about the Newland's law of octaves. Thanks.